Hi guys, welcome again to Simplified RSA. The guys makes it looks easy. I'm Mr. Maiman and we are your #1 learning channel / platform. Today we did some trigonometry, but then we are just doing the intro. Like normally I do have a video I've done previously about this, but then this time around I was communicating with the student. I'm just gonna put the video now. I hope everyone enjoys it. This is how the conversation went. Welcome to Introduction to Trigonometry, by the way. Do you know the guy named Pythagoras?
The what?
A guy by the name Pythagoras. Do you know him?
No, I only know the Pythagoras theorem.
Oh yeah, you only know the theorem.
Yes.
What
I
does
didn't
the
even know that there was a guy involved.
So when you think of Pythagoras theorem, what comes to your mind?
The theorem of Pythagoras, that's it.
So Pythagoras is actually a person. I'll send you the picture of the person just to see. He's an awesome scientist. So but what do you know about Pythagoras theorem then?
I know that it's used in order to find both x's if we have an equation that has three I forgot the name, but three, yes.
3 sides. So the
Yes.
story is that it starts with a triangle, but not just a triangle, a right angle triangle. And then
Okay.
it's a triangle, so it obviously have 3 sides. So we have the y-axis, we have the x-axis, and then we have the height, according to the theorem, yeah, Pythagoras. So if we have the angle theta, that's when we then determine the opposite side of the angle theta, the adjacent side of the angle theta, and the hypotenuse side of the angle theta. Does it ring a bell now? Are we going somewhere?
Yes.
But do you still remember the equation of a circle?
I remember there's an R, but I don't remember the full equation.
Yeah, that R. I already had something drawn here. The R
Radius.
for the radius. Yes. So the formula for a circle, it says radius squared is equals to, because a circle is given by, from the origin, this is the formula of a circle that has the center 0 and 0. So the origin is 0. Somehow when the radius go to the circumference of the circle, there should be a point there, and the point is x and y, right? And then
Yes.
now the formula for a circle states that r squared is equals to x squared plus y squared, right?
Yes.
And then somehow, when we come to Pythagoras theorem, we have the same situation. So now, with Pythagoras theorem, the triangle must be a right angle triangle, like we stated, ne?
Yes.
And if there's an angle theta there, we say the side opposite to the angle theta, we call it the opposite. Again, let me just draw it properly. And then the side or the floor of the angle theta, we say is our adjacent, right?
Yes.
Call this our hypotenuse. We talk about 3 trigonometric functions. Some books may say it's 6 of them, but it's actually 3. It's just that the other 3 represent the reciprocal of the 3. I think you know them. So we have the sine, and get abbreviated by sin. And then we have the cosine, abbreviated by cos. And then we have the tangent, abbreviated by tan. You are familiar with this, right?
Yes.
And they have 3 reciprocals, which I'm going to give them respectively as well. We have the cosecant, which is the reciprocal. So this is what we have so far. We have the sine, and the abbreviation for sine, it's sin, like that. And then we have sine abbreviated like that, and then we have the tangent abbreviated like that, right? And then
Yes.
from our Pythagoras theorem, considering the angle theta, if now we want to determine sine theta, we say sine theta, according to this, is equals to the opposite side from the theta is equals to the opposite side divided by the hypotenuse. So sine is equals to opposite, sine theta is equals to opposite over hypotenuse. Do you know what is cos? Cos theta? Can you guess?
Can I guess that?
Cos theta. Do you know what is cos theta?
Yes.
What?
Opposite over hypotenuse over opposite.
So cos theta is actually adjacent over hypotenuse. Right? And then do you know what is tan theta? Tan theta is opposite over adjacent. Let me just put that one there. Opposite over adjacent. But I know that somewhere back then, someone might have told you about something like that, like this. Are you familiar with the word? Actually, let me use different colors there so it can be more nicer. Does this rings a bell to you, Mr. Man? Sokatoa. Can you hear me, Mr. Man? Mr. Clifford?
Yes.
Oh, what's up? Back. I don't know, man. Like sometimes your sound is cutting. I go to
If this side dish network is not that good.
like load sharing, ne?
Yes.
Sorry, man. I was saying, are you familiar with this word, Sokatoa? Mr. Ben, can you hear me though?
Yeah.
Can you hear me from Zoom?
I can't hear you.
You can't hear me from Zoom. But now, if I call you like this, are you able to access the screen of your Zoom if I can talk to you over a call while you're watching from your screen that side?
Yes, I can.
So can we use this audio while you're watching from Zoom just to finish up this part, and then we're gonna check what's wrong with the sound.
Okay.
All right, cool. So where were we? I was still asking were you hearing the part where I was asking you, are you familiar with the word Sokatoa?
Yes.
Yes. So we use the word Sokatoa to simplify how to understand or how to put these things in order or to make them make sense. So Sokatoa is the same as, like if you see here, I try to use color so you can understand that S is for sine, C for cos, and T for tangent, right?
Yes.
So we say sine is opposite over hypotenuse, the way we do here, opposite over hypotenuse. And then we say cos is adjacent over hypotenuse as it is adjacent over hypotenuse. And then tan is opposite over adjacent the way it is here. But then I was like saying to you, as much as now we get that Pythagoras theorem, it's worked out like this. Somehow, when we look inside our circle, if that's our radius, the radius, it forms some points there, x and y. From those x and y, if we contract something, it does indeed formulate some right angle triangle there with an angle theta there. So if we put theta there, it's the very same way as Pythagoras. So if I say sin theta is equals to opposite over hypotenuse, knowing that the angle theta is here, do you understand when I say this is my y intercepts of this for this point? And this is the x part. So theta is opposite over hypotenuse, meaning theta, sine theta will be equals to opposite over hypotenuse. Do you get it, Mr. Man?
Yes, I do.
That's why we say sine theta is equals to y over r as per this part here, if we use a circle instead of just the triangle to explain Pythagoras theorem. And cos theta now, because cos theta is adjacent over hypotenuse, when we look here, adjacent is x and the hypotenuse is r. So here we'll have that cos theta will be x over r. Do you see how it works, Mr. Man? Automatically, this makes tan theta to be opposite over adjacent. So opposite over adjacent is opposite over adjacent. So tan theta is going to be y over x. So this is as simple as that. Right? This is the summary of the universe. Yeah, trigonometry. Right?
Okay, well,
Before I proceed, Mr. Man, do you have any question?
no.
No. So far, we've spoken about 3 trigonometric functions, and then they have their reciprocals, like I said.
Well, I thought you were saying something.
Yeah. So they have reciprocals, which is like the inverse is, let me not say inverse, I'll confuse you. So this trigonometric functions, they have reciprocals. Do you know the reciprocal for sine theta? So the reciprocal for sine theta, it's cosec theta. It's cosecant, but we denote it by cosec. So cosec theta is equals to now, is the opposite of what sine theta is. So cosec theta is equals to hypotenuse over the opposite. Do you get it, Mr. Man? I think you see where this is going. The reciprocal for cos theta. The reciprocal for cos theta is sec theta, which stands for secant, but we denote it as sec. So sec theta is also equals to hypotenuse all over the adjacent, because it's the reciprocal of this, so it's the upside down of cos theta. And then for tan, the reciprocal for tan theta is cotangent theta, and then cotangent is the very same way as we do, is going to be the adjacent over the opposite. So this is what we have so far. We have 3 trigonometric functions, sine, cos, and tangent. And then they have 3 reciprocals. The reciprocal for sine is cosec theta. So the reciprocal for sine theta is cosec theta. The reciprocal for cos theta is sec theta. The reciprocal for tan theta is cotangent theta. And we say sine theta is equals to opposite over hypotenuse. Cos theta is equals to adjacent over hypotenuse. Tan theta is equals to opposite over adjacent. And then we say, to understand or remember this, you must familiarize yourself with the word SOHCAHTOA. And then also we can represent the opposites in terms of y, r, and x from our circle there. So another way to represent sine theta, if you don't want to use opposite over hypotenuse, you can say it's just y over r. Same applies with that. So meaning also here, cosec theta, it's going to be r over y. Do you get how it's going, Mr. Man? And then for tangent there, we'll have x over y. So this is our summary for the entry level. And then now, at times, they give us something like this. Okay, Mr. Man, so now, the way we apply our trigonometric functions, it's so diverse. This is just the intro. We're going to talk about a lot of things. But now I want us to have the first basic example where we're going to try to find sine theta in a given triangle, yeah, Pythagoras theorem together. This one we're going to do it together. Ne? So suppose we are given this, we have to find sine theta. We know that sine theta is equals to opposite over hypotenuse. So from theta, this is going to be equals to 2 over the hypotenuse is r. So I don't know the value of r, but then I know that sine theta is equals to 2 over r because it's opposite over hypotenuse. Meaning, in this case, I'll have to find r first. And to find r first, and then I use Pythagoras theorem. Therefore, r squared is equals to 3 squared plus 2 squared. Therefore, this is going to be 3 squared will give us 9 plus 2 squared will give us 4. Therefore, our r squared is 13, but that is r squared. It means if we want to get r, we're going to put square roots both sides. Therefore, our value for r is just going to be square root of 13. That means then our value for sine theta is equals to 2 over root 13, because that's what we find as the value for r. R is equals to square root of 13. I don't know if you can hear me, Mr. Man, but this is how it's done. And so that is that with our introduction to trigonometric functions, as well as the Pythagoras theorem and all the stuff we're talking about now. Join us on the next video as we explore more on this topic of trigonometry. And yeah, I think I'm going to stop from here. I'm Mr. Maimane. This is Simplified RSA. The guys makes it looks easy. Please make sure you subscribe on our YouTube channel. Follow us on Facebook. Follow us on X. Follow us on Instagram. Follow us on TikTok. And now you can access our learning channel through Spotify. All you need to do is just to go to your Spotify app and search for learning channel, or alternatively, you can search for simplified_RSA.